Now that you know what a basis is, you should know that some bases are more useful than others. In particular, there is one basis to rule them all called the eigenbasis. The eigenbasis is tremendously useful, in particular for machine learning applications such as principal component analysis, as we mentioned before. Here's how eigenbases work. So let's look at the linear transformation corresponding to the matrix with entries 2, 1, 0, and 3. And we're going to see how it acts with respect to the fundamental basis. So this basis has two vectors. The vector 1, 0, which when you multiply by the matrix, you see that it gets the vector 2, 0. And the vector 0, 1, which when you put in the product, you get the vector 1, 3. So this square on the left goes to this parallelogram on the right, and the rest of the plane follows. So this is also called a change of coordinates, or a change of basis, because that's exactly what you're doing. You're going from the square coordinates in the left to the parallelogram coordinates in the right. But that's something you've already seen. Now let's get to something more interesting. The choice of the square was very arbitrary. Let's actually pick a different basis and see what happens. So let's pick again the vector 1, 0 that goes to the vector 2, 0. And as a second element of that basis, let's pick this vector 1, 1 just to see what happens. And that goes to the vector 3, 3. So this parallelogram goes to this parallelogram. Now what is special here? Well, notice that the sides of the two parallelograms are parallel to the corresponding one on the other basis. And that is very special. And notice that the rest of the plane also follows. So because these sides are parallel, then what we're doing to the plane is we're stretching by 2 in this direction, the horizontal direction, and stretching by 3 in this diagonal direction. So this is a very special basis. It only consists of 2 stretchings. That is what's called an eigenbasis. It's a very, very special way of looking at a linear transformation with respect to a basis that sends a parallelogram to another parallelogram of size parallel to the original one. And why is that useful? Well, let's say that you want to find the image of the point 3, 2. So you can multiply it by the matrix and get 8, 6, which is over here. But you can also express that point as a combination of elements in the basis. What does that mean? That we find a path to get to that point using the 2 directions that we have. And now the linear transformations corresponds to stretching the horizontal vector by 2 and the vertical vector by 3. And so this really simplifies the linear transformation. It just consists of 2 stretchings. So the 2 vectors in the basis are going to be called the eigenvectors, and the stretching factors, the 2 and the 3, are going to be called eigenvalues. And eigenvalues and eigenvectors are tremendously important in linear algebra because they really, really simplify our calculations.